All right, this will be for the con assignment, empirical rule. So some review before we get started for about normal distributions. Okay, statisticians noticed the same shape coming up over and over, so they named it the normal distribution. Okay, and I'll explain what these percentages mean in a moment. All right, normal distributions have the following features. Symmetric bell shape. Okay, we know symmetric means it's the same on both sides, and the bell shape is because it's shaped like a bell. Okay, so you can see that right there. The mean and median are equal, both located at the center of the distribution. All right, so you can see this line is your mean, okay, going right down the middle. It's right in the middle of your bell curve, okay? Let's see. Okay, and these numbers on the bottom are just your z-scores. All right, so remember the z is positive going to the right, means that's greater than the mean, and the z-scores are negative going to the left, that means it's less than the mean. Okay, now it says that 68% of the data falls within one standard deviation of the mean. Okay, so here's our mean at 0. All right, and if we start at the mean and go one standard deviation to the right, all right, I'll do it in a different color. One standard deviation to the right and one standard deviation to the left. We are at z equals 1 and z equals -1. Okay, so if we closed off the curve from here to here, this would represent 68% of the entire curve. Okay, of course, the whole curve is 100%. So we have 34% to the right and 34% to the left, and that's 68% going from z equals 1 to z equals -1. This is one standard deviation from the mean in each direction. All right, next up, 95% of the data falls within 2 standard deviations of the mean. Okay, so again, we're going to go to the mean, which is right down the center, and we are going to go 2 standard deviations to the right and 2 standard deviations to the left. Okay, so we are right here at z equals 2, and right here at z equals -2. Okay, so if you added 13.5 plus 34 plus 34 plus 13.5, this portion is going to be 95% of the entire curve. Okay, so 2 standard deviations, 1, 2 to the right, 2 standard deviations to the left, 1, 2, and that represents 95% of your data. And finally, 99.7% of the data falls within 3 standard deviations. So let's see. Again, we start at the mean. Okay, we go 1, 2, 3 standard deviations to the right, 1, 2, 3 standard deviations to the left. So we are right here and right here. Okay, we almost have 100%. We almost have the whole thing, except for this piece right here is 0.15, and this piece right here is 0.15. Okay, so the whole thing is 100%, but if we subtract 0.15 and subtract 0.15 again, that is the same as 100 minus 0.30. I'm sorry. Yes, 100 minus 0.30. And that is 99.7%. So 99.7% of the data is within 3 standard deviations of the mean. Okay, it goes from z equals -3 to z equals +3. Okay, so on to the assignment. The lifespans of zebras in a zoo are normally distributed. Okay, the average zebra lives 20.5 years. That's your mean, and the standard deviation is 3.9. Use the empirical rule to estimate the probability of a zebra living less than 32.2 years. Okay, the easiest way to do this, in my opinion, is to get a z-score first. If you recall the formula for the z-score, z equals x minus mu divided by sigma. Okay, so x is the actual value. That's the data point that you're given. Mu is your mean. That's 20.5. And sigma is your standard deviation. Okay, in case you forgot what the symbols mean, let me write those out. Okay, so I wrote everything out. X is the data point. Greek letter mu is the mean. And Greek letter sigma is your standard deviation. So let's calculate our z-score. Okay, x is 32.2. Mu is your mean, that's 20.5. And your standard deviation, sigma, is 3.9. Okay, I'm going to do this on the calculator. Okay, and I got 3 exactly. Now, they want to know the probability that the zebra lives less than 32.2. Okay, so I am going to give you a copy of the normal distribution curve, but for now we're going to remember that z equals 3, and we want to go less than that. So let's look at the curve once again. Okay, so we said from our calculation that z equals 3. Okay, so we're right here, and we want to find the probability that it's less than that. So it is all of this data that is to the left of the 3. Okay, now of course, we can go and add all of these percentages. Okay, but you don't have to do that, because we said before the entire curve represents 100%. Okay, and this piece right here is the only piece that is not included in that 100%. So it is just going to be 100% minus 0.15%. Okay, and that is going to be 99.85%. Okay, so I will give you copies of this so you can write on your own paper. So we said 99.85%. All right, the percent sign is already there. Okay, almost the same problem. Lifespans of zebras are normally distributed. The average zebra lives 20.5 years, and the standard deviation is 3.9. All right, so average is the same as mean. The Greek letter for that is mu, and standard deviation, the Greek letter for that is sigma. Okay, and now we have to find 2 z-scores, because they want the probability that the zebra lives between 16.6 and 24.4. So we have to do the z-score twice. Okay? So this is going to be an x value, and this one here is also going to be an x value. Remember, x is the actual data point. So the formula for z, okay, it's going to be x minus mu divided by sigma. Okay, so for the first one, 16.6 is x minus mu 20.5 divided by sigma, which is 3.9. Okay, I'm going to do that on the calculator in a moment. But in the meantime, let's do the z-score for the other x. Okay, the first x was 16.6, but the other x is 24.4. So we start with x, 24.4, and we subtract mu, that's 20.5. And again, we divide by sigma, which didn't change, 3.9. Okay, I am going to do each of these on the calculator and get z-scores. Okay, so when I did these on the calculator, one of them I got -1, and the other one I got +1. So we want to find the probability that the zebra lives between these two numbers, and the z-scores for those two numbers are 1 and -1. So let's go to our curve. Okay, so we are between 1 and -1. All right, so if I go to z equals 1, I am right here. And if I go to z equals -1, I am right here. All right, and so they want the probability that it's in between. So all you have to do is add 34 and 34. Okay? And of course, we know 34 plus 34 is 68% of the entire curve. Okay? And did I really even need to add those? Not really, because we said before, 68% of the data falls within one standard deviation of the mean. So we actually knew that already without adding it. All right, but if you want to write it on your paper, like I said, I'll give you a copy of these, and you can use it to add the percentages. So it's 68%. So just type in the box 68%. All right. All right, last one. The lifespan of lions in the zoo are normally distributed. The average lion lives 10 years. The standard deviation is 1.4. Estimate the probability of a lion living less than 7.2 years. All right, z-score is always first. That's going to be x minus mu divided by sigma. Okay, so x is our data point, that's 7.2. Mu is our average or mean, so that's a 10. And sigma is your standard deviation, that's 1.4. So I'm going to do this on the calculator. Okay, and I got z equals -2. So we're going to go to our curve, all right, and we want the probability that the lion lives less than that. Okay, so less than is always to the left, and the z-score is -2. Let's check it out. Okay, we said the z-score is -2. Okay, so on the bottom is your z-scores. Right here is -2. All right, so that's at this bar right here. And it said less than, so we're going this way. All right, so the only numbers, percentages less than, is going to be this and this. All right, so we're just adding these two because we're only doing this small piece of the curve. So we have 2.35 and we have 0.15, and that's going to be 2.50. All right. So this small piece of the curve represents 2.50% of the whole thing. Now, just for your information, if the problem had said greater than that number, then it would be from here going this way, okay? And instead of adding, you would just subtract this piece from 100%. So you would subtract this and this from 100%, and you would get this whole thing. Or, of course, you can add these numbers, all right, and you'd get the same thing. So you can subtract or add. You can subtract from 100% or you can add, same thing. But anyway, the probability that it's less than that is only 2.5% because it's just this piece of the curve right there. All right, so it's just going to be 2.5%. All right, so that's it.